All right, today we're going to be talking about significant figures, also known as sig figs. So if you look at this population sign for St. Paul, does anything strike you as a bit strange about it? Well, one thing that might strike you as strange is how specific it is. 287,151 people. What do they do if someone moves in? Should they change the sign? I'm pretty sure they don't. So why would you have that sign as being that specific or that precise if it's not true? Here we've got a person who moved into Grayson, and they wanted to fix the sign, so they fixed that. If you were to look at a street sign or a population sign for Pekin, wherever this is, would you, and you counted up all the people in Pekin, would you expect to count exactly 33,900 people? No, you'd expect to count about that many people. You would expect there to be about that many people, and that's what those zeros indicate to you without you being necessarily conscious of it. Is that means they mean about, and that has to do with significant figures. So usually referred to as sig figs by me, and it's not whether or not a number is important or not. It has to do with the precision of a number. So there was an early height of Mount Everest done in the 1800s, and he calculated that the height, his calculator, he didn't have a calculator, his math came out to be exactly 29,000 feet. But he lied when he reported it. He reported it as 29,002 feet. Why would he have done that if his math came out to be exactly as 29,000? Well, he wanted it to look more precise. He wanted it to look reflect the precision that he put into it. You can see the last measurement. He didn't quite fudge his numbers enough. He was off by 26 feet, but still pretty good for whatever methods he used back in the 1800s. So we're not doing that. So these are the rules for when a number is a significant figure or not. The first rule is really easy. Any number 1 through 9 is always automatically a significant figure. So basically that leaves out one number, and that's 0. The remaining rules are about whether or not zeros are significant, and that becomes so any number 1 through 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 is always a sig fig. So those are the easy ones. It's the rest of the rules are when 0 counts as a sig fig, and this includes one of them. If you put a 0 with a line over it, what I'm telling you is that is a sig fig. I'm not trying to tell you that it means that it repeats. That does not mean that in this class. I'm telling you that 0 is a significant figure. So the 1 and the 2 are sig figs. The 4, 5, 1, 2, they're all 1, 2, 3, 4, 5s. They're all sig figs. These are 3 sig figs, the 3, the 2, and the 2. And here we've got the 1, the 4, and the 0. And I'm telling you with the line over the 0 that 0 is a sig fig. So that gives me 3 sig figs in that number. Okay, so that's rule number 1. Rule number 2 is, there we go. Zeros between sig figs are always sig figs. Okay. So I call this the sandwich rule. So here we've got a 3 and sandwiching a 3 and a 2 sandwiching a 0. Because this is sandwich, that's a sig fig, so there's 3 sig figs. And here we've got a 0 sandwich between a 4 and a 5. I'm telling you that is a sig fig, and rule number 1 tells us that everything else is a sig fig. So that has 5 sig figs. Skipping down to this one, I've got a 1 over here and another one way down over here. It doesn't have to be sandwiched directly. It can be, as long as it's between 2 sig figs, it's a sig fig. So all of these zeros are considered sig figs. It doesn't matter if it's to the left of a 0, or I'm sorry, to the left of a decimal place or right of the decimal place. If it's sandwiched between sig figs, it's a sig fig. And here, this 0 with a line over it, I'm telling you, is a sig fig, which means this 0 right here is a sig fig as well. So this has 5 sig figs. So that's sandwich rule. Number 3, we've got the left rule, and this tells you whether or not zeros are. So this is the left rule. The zeros to the left of all the non-zero numbers, meaning the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or no, not 10s, 9s. The zeros to the left of all those numbers, they're never significant. Okay, it doesn't matter if they're to the right of a decimal place. Doesn't matter if they're to the left of a decimal place. Zeros to the left of all the 1, 2, 3, 4, 5, 6, 7, 8, 9s are never sig figs. Okay. All right. Now this rule, this is, well, they're all important, but this one is a little easier to make to screw up. Zeros to the right of a number and a decimal. Okay, if a zero is to the right of a sig fig and a decimal place, okay, then it's a sig fig. Okay, so in this case here, these zeros are to the right of a sig fig, but they're not to the right of a decimal place, which means they're just placeholders. Okay. These two zeros, according to the left rule, are not significant. This zero here is the right rule, is to the right of a number and a decimal place. It's to the right of a sig fig and a decimal place. Okay, might be easier just to say number. So this zero is a sig fig, so that's got 2. So here, it doesn't have to be directly to the right of a number. It just has to be on the right side of a number. So these zeros are to the right of the 6 and a decimal place, which makes them sig figs. Okay, which makes these two zeros sig figs according to sandwich rule. So this has got 6 sig figs. This number here, we've got this 0 is to the right of a number and a decimal place. It's on the right side of the 7 and the 8, so and the decimal place, so it's a sig fig. And this 0 is a sandwich rule, so it's a sig fig. The fifth and, well, more or less last rule is that sig figs that are on numbers that are counted are infinite. And so any number that has been counted or is true by definition, the numbers have infinite sig figs. Remember that little sideways 8 infinity sign. So, for example, if we count 4 apples, we don't mean that we have about 4 apples. If I count 4 apples in my basket, I've got exactly 4 apples, so that number is infinitely precise. If you count the number of people in the classroom, there's not about 18.5 people. There's exactly 18 people in the room. 12 inches in 1 foot, that's true by definition. So the 12 and the 1 both would have infinite sig figs. Water freezes at 0 degrees C is true by definition. So this number the 0 would have infinite sig figs. And this one doesn't look like it's true. That's true by definition, but this is also true by definition. So that 2.54 actually would have infinite sig figs. Now, I'm not going to be tricky here. Like if something is like bowling balls, there's 7 bowling balls. I'm not trying to be tricky here. That was obviously counted, so that number would have infinite sig figs. The very last rule, I guess this is number 6, is that when you look at a number in scientific notation, anything that comes in the times 10 to the, okay, comes before the times 10 to the is a sig fig. So 2.4 those are all sig figs, and these obey the other rules. The main point of this rule is you ignore the times 10 to the when you count sig figs. So the 2 and the 4 are sig figs. The times 10 to the is not. So 2 sig figs. 5 times 10 to the 9th, it's just the 5 that's a sig fig. Okay, and that would be a sig fig according to all the other rules anyway. So again, here all the numbers in the coefficient, the number times 10 to the are significant. Okay, so let's practice. So pause it for a second and see how many sig figs you think are in these numbers. So you pause. I'm going to keep going. The first number has got 2 sig figs. This 1 and the 2 are sig figs. This does not meet right rule. It's to the right of a number but not a decimal place. So this is not a sig fig. Okay. 6306. The 6, the 3, and the 6 are always significant. Sandwich rule says the middle 0 is a sig fig, so that's got 4 sig figs. This number. Left rule tells me that these zeros are not significant. They're to the left of all the 1, 2, 3, 4, 5, 6, 7, 8, 9s. Okay, and this 0 is significant based on either rule, either sandwich rule or right rule makes this 0 significant. So this has got 4 sig figs. So all of this is significant using sandwich rule. I look at this 0 and I see, does it meet right rule? It's to the right of a number and a decimal place. So therefore it is a sig fig. So that has 5 sig figs. This number, left rule tells me these are not sig figs. And right rule tells me these are sig figs. So that gives me 4 sig figs. 360,000 oranges. Did I trick you? Did I trick you? That's got infinite because we counted oranges. And this last one, 2.40, that's got 3 sig figs. Only the coefficient counts. Okay, the guess digit. This will make more sense when we start talking about measuring, but the guess digit is just the furthest sig fig to the right. That's all it is. So you look at the sig figs and you look at which one is closest to your right hand, and that's the guess digit. So 654, all 3 of those are sig figs. So this 4 is the furthest one to the right, so that is my guess digit. Here I've only got 1 sig fig, the 5. This is left rule, tells me these are not sig figs. So the 5 is my sig fig. Okay, I've got an 8 and a 5. Do these follow right rule? They're to the right of a number but not a decimal place. So these zeros are not significant. So the furthest sig fig is the 5. 40.00. The question is, do these follow right rule? They do. They're to the right of a number and a decimal place. So these are significant. Sandwich rule makes that significant. It's got 4 sig figs. So the guess digit is the furthest 0 to the right. Okay. Guess digit. So that'd be the 2 and 120. The 6 and 6306. The 9 and the 0.0 whatever. And then, would this 0 be significant? Would this 0 be my guess digit, yay or nay? Does it follow right rule? It's to the right of a number and a decimal place. So that means, yes, it is a sig fig, and that is my guess digit. Okay, well, a few more practice. So, left rule, well, go ahead and figure out how many sig figs you think you have in these. I'll give you a minute. Well, actually, you pause it, and I won't wait. So the 5 and these 3 zeros are all significant. So these 4 digits here are sig figs. The 5 and the 0 is to the right of it, and the 0 is the guess digit. What's the guess digit in 360,000? Well, the question is this 0 a sig fig? If so, it would be my right. It would be my rightmost sig fig. Well, does it follow right rule? It's to the right of a number, but not a decimal place, which means these are not significant. These are not significant. So the 6 is my sig fig, or is my guess digit. 890. The question is this 0 over here significant? Does it follow right rule? Is it to the right of a number? Yes. Is it to the right of a decimal place? Yes. So that is my guess digit. What about in 10,000 here? I've got a line over this. So remember what that line means. It doesn't mean it's repeating. It means I'm telling you this is a sig fig. So do these zeros follow right rule? They're to the right of a number, but not a decimal place. So these zeros are not significant. I'm telling you this is a sig fig. So we've got 3 sig figs. So that means that 0 with a line over it is my guess digit. Okay. And that is it for notes on sig figs for the day.